Assalamu alaikum warahmatullahi wabarakatuh. Good morning, everybody. Today our lesson is lesson 6 in chapter 8, vectors. Before we start, we have warming up. Find AB, find the length of AB. We have the point A, 0 and 15, the point B, 17 and 0. So we have the distance formula. We can substitute x1, y1, x2, y2. Okay, we have the rule, root, brackets, x2 minus x1 all power 2 plus bracket y2 minus y1 all power 2. So it will be root 514. The second one, a negative 4 and 2, b 4 and negative 2. So it will be 4 and root 5, 4 root 5. Now solve each equation. Remember, when we have the unknown in the numerator, we multiply cross product. So x equals 7 cosine 26, which is equal 6.3. And here to find y, multiply 7 by sine 26, it will be 3.1. And here to find measure angle B, we use the inverse function of tan negative 1. So we write tan negative 1 of 41 over 53. It will be approximately 38 degrees. Here shift tan 13 over 11, it will be approximately 50 degrees. Now today, by the end of this lesson, you can find the magnitude and the direction of a vector. Use vectors and vector addition to solve real-world problems. We have new vocabularies: vector, component form, magnitude, direction, equal vectors, parallel vectors, resultant vector. You know, in science, the speed and direction of an object moves can be represented by a vector. So the vector is a quantity that has both length and direction. So the vector is a quantity that has both length and direction. You can think of a vector as directed line segment. So the vector is a directed line segment. What the meaning of directed line segment? It's line segment, okay, line segment. We know its start point or initial point and its terminal point. So it's a line segment has direction. And the vector may, so we have this is directed line segment. So this vector, okay, has initial point A and terminal point B. So AB vector or vector denoted by this symbol, okay, V, and the symbol of vector like the ray, but with one part only. A vector can also be named using component form. What is the component form? It's two brackets like this. This is a bracket, X and Y. This is component form of a vector. Lists the horizontal and the vertical change from the initial point to the terminal point. Let's see if the initial point C and the terminal point D. So the horizontal change from the initial to the terminal, horizontally 2 units and vertically 3 units up. Okay, so you can write it in component form as 2 and 3 between this special type of brackets. Now, example 1, write the vector in component form. We know that the component form is the change, horizontal and vertical changes from the initial point to the terminal point. So stop or start at the initial point h. So we are here. To reach the point G, we need horizontal change. How many units? Count with me. 1, 2, 3. So 3 units to the left, which is -3. And how many units up? 1, 2, 3, 4, 5. So 5 units up. So we have -3 units and 5 units vertical. So we can write it in component form by -3 and 5 in the two brackets of component form. Second part, write the vector in component form. The vector is mn. If I know the two coordinates of the 2 points m and n, so we can subtract the coordinates of the initial point from the coordinates of the terminal point. It means start with the terminal minus the initial. Terminal minus initial. Here the terminal point n, so start with n, minus m. So when you have a vector, you can say end minus start, or terminal minus initial. So we have here 2 minus -8 and -7 minus 1. Simplify it, you will find the component form of the vector mn as 10 and -8. Check it out, stop the video and try to solve alone. Now check your answer. The magnitude of a vector means its length. The magnitude of a vector, it means its length. The magnitude of a vector written as the absolute value like this of the vector, or like this, okay? So when a vector is used to represent speed in given direction, the magnitude of the vector equals the speed itself. For example, if a vector represents the course kayaker pedal, the magnitude of the vector is the kayaker's speed, okay? Now let's see example 2, finding the magnitude of a vector. Draw the vector -1 and 5 on the coordinate plane. Find its magnitude to the nearest tenth. So draw the vector on the coordinate plane, use the origin as the initial point, then -1 and 5 is the terminal point. It will be like this. This is the vector. Now to find the magnitude of this vector, we will use the distance formula. So the distance formula, we want to find the distance between the origin point and the point -1 and 5 as x1, x2, 0 and 0, xy, y1, 0 and 0, x2, x2, y2, -1 and 5. And we use the distance formula. Then the magnitude of this vector is root 26, which is approximately 5.1. Now check it out too. Let's check your answers. Okay, now the direction of a vector. What the meaning of direction of the vector? It's the angle that it makes with horizontal line. the angle that it makes with a horizontal line. This angle is measured counterclockwise from the positive x-axis, counterclockwise from the positive x-axis. So the direction of this vector AB is 60 degrees. Here, if I ask you the direction of a vector can also be given as bearing relative to compass directions, north, south, east, and west. AB has a bearing of north 30 east, north 30 east, or 30 degree east the north. Let's see example 3. The force exerted by a scalar is given by the vector 1 and 4. Draw the vector on the coordinate plane. Find the direction of the vector to the nearest degree. Let's draw the vector first. We know that. Take the origin point as the initial point. Now to find the direction, we can draw right triangle ABC like this. Just draw this altitude as shown in the angle formed by the vector and the x-axis. We want to find it. We study how to find this angle in the previous lesson by using the tangent of angle A. Tangent of angle A, which is opposite over adjacent. The opposite here is BC and the adjacent is AC. So tan A is equal to BC over AC, which is 4 over 1. So to find measure angle A, we use the inverse function of tangent, which is tan negative 1 of 4 over 1, which is 4. So the angle equals 76 degrees. Also, you can solve this question directly. You can observe now that measure of the angle is equal to tan negative 1 y over x. Y over x in one step. Y over x. So tan negative 1, 4 over 1. Tan negative 1, 4 over 1, which is 76 degrees. Check it out, 3. Now check your answer. You can solve it directly. We said y over x, 3 over 7, tan negative 1, 3 over 7. Now, two vectors are equal vectors if they have the same magnitude and the same direction. For example, we have two vectors now, vector u and vector v. Equal vectors don't have to have the same initial point and terminal point. We said we have only two conditions. They must have the same magnitude and the same direction. Here you will observe that they have the same length and also the same direction. They are parallel. Now, two vectors are parallel vectors if they have the same direction, or if they have opposite directions. They may have different magnitudes. For example, vector W is parallel to vector X. Equal vectors are always parallel vectors, but not any two parallel vectors are equal. Okay? So any two equal vectors are parallel, but not necessary the two parallel vectors to be equal. Now let's see example 4. identifying equal and parallel vectors. Number A, letter A, equal vectors. Where is the equal vectors here? We said the equal vectors, they have the same magnitude and the same directions. So here, IJ and OP are equal because they have the same magnitude and they are parallel, means they have the same directions. Parallel vectors, you can write the two equal, IJ and OP. Also, you can write the other pair, KL and MN. Check it out for. Now check your answer. The last part of our lesson, the resultant vector, is a vector that represents the sum of two given vectors. To add two vectors geometrically, you can use the head to tail method or the parallelogram method. Let's see, we have two methods to add two vectors geometrically. We have the first one, head to tail method. Look here, if I start from this point, the first vector u, okay, we start from here and we end here. We add this vector to another vector, the second vector v, but the second vector must be start from the end point, of the first vector. So the initial point of the second vector must be the end point or the terminal point of the first, and then go to its end or its terminal. So the resultant vector or the addition of the two vectors, if you start from the first point and end with the last terminal point, so this is the equivalent, or this is equivalent to the sum of the two vectors. This is the first way. So u plus v, you can start here and end here, okay? The parallelogram method use the same initial here when I add u and v, if they are both starting from the same initial point, but one go in this direction and one go in another direction like this. So we will complete a parallelogram, draw two lines opposite. You know, in the parallelogram, each two opposite sides are equal in length, okay, and the parallel. So the diagonal of this parallelogram represents the resultant vector of the two vectors which have the same initial point. Now, how to add two vectors numerically? We just add their components. Means if the first vector x1 and y1, second vector x2 and y2, when we want to add them algebraically or numerically, we just add x1 plus x2 and put them in the first coordinate, y1 plus y2 and put them in the second component. Okay, now example 5, an airplane is flying at a constant speed of 400 miles per hour at a bearing of north 70 east. A 60 mile per hour wind is blowing due north. What are the plane's actual speed and direction? Round the speed to the nearest tenth and the direction to the nearest degree. First, we want to sketch vectors for the airplane and the wind. Look, the airplane from the given, its magnitude of its speed is 400 mile per hour. Okay, we said here 70 degrees. Okay, 70 degrees east the north. So we put 70 here between north and east in the first letter here. Okay, and for the wind 60 miles per hour. Okay, due to the north, it means its direction here the north. Now write the vector of the airplane in the component form x and y. So the airplane's vector has a magnitude of 400 and makes an angle 20 degrees with the x-axis. Okay, so we can do it directly like this. X coordinate in any question, x coordinate is equal to the magnitude 400 times cosine the angle, the magnitude times cosine the angle. So 400 times cosine 20, and also y equals the magnitude times sine 20. Now ask yourself, Mister, why we use 20? Why we didn't use 70 like the given in the question? Because we need the angle which the plane makes with x-axis, the angle which the plane makes with x-axis. So look here, we need this angle which is 20. Now the two coordinates or the two components of the plane are 375.9 and 136.8. Let's write the vector for the wind in component form. Because the wind moves 60 miles per hour in the direction of y-axis, so it has a horizontal component of 0 because it's on y, so you can write it like this, 0 and 60 like this. Now find and sketch the resultant vector AB and add the two components of the airplanes and the wind vectors. So we just add them like this. Okay. If you want to find the magnitude and direction of the resultant vector, the magnitude of the resultant vector is the airplane's actual speed or ground speed. So the magnitude, which is the distance formula like this, or you can cancel this 0 and say it's root x squared plus y squared directly. Now the direction. So the direction we can find it in one step by writing tan negative 1 y over x. So tan negative 1, 196.8 over 375.9. So you can do it directly as this, which is 28 degrees or 62 degrees north east, okay, or east the north. Now check it out. 5. Check. Now this is lesson quiz. Please try to solve it and send it to me. Goodbye. See you tomorrow, inshallah.